So my name is Robert Valenti, and this is my presentation of the spectroscopy of simple molecules. Alright, so the intro, so what you'll be learning throughout this presentation, you'll be learning what an IR and NMR are, how to examine them and how to use them, and also how to use them to identify your three unknowns that are given throughout the lab. Alright, NMR. So what is NMR? NMR is the absorption of a radio frequency region, which leads to the excitation of a hydrogen nucleus. Also, it measures the electromagnetic radiation that is absorbed. And lastly, the more complex the molecule, the more vibrations it'll have, the more hydrogen atoms, and the more peaks it'll have. IR is next. What is IR? IR is the absorption of a photon in an infrared region, which leads to the increase in energy. And the next two about electromagnetic radiation and the complex molecules are the same as your NMR. Alright, so this chart here, this is given to you. What this is the functional groups, how to identify them with their absorption range in your IR spectra. Your problem to solve. So after you fill out your IR and NMR experimental charts, which are placed here, you use these to identify your three unknowns, which are given throughout your lab. Alright, this right here is your functional groups and the 15 possible molecules that you can have. Your next is NMR. This is for each 15 molecules again, the number of peaks and the ratios in each. Alright, these three right here, these were my unknowns. I had 88D, 88J, and 88L. These are just a number of peaks and ratios to go along with it. Alright, so first off, we're going to start with 88D. On the left right here are all the functional groups. The ones highlighted in red and circled are the ones that were present. So firstly, oxygen to hydrogen bond was present right here in the bottom left. And the reading for that was, the absorption was 3,368.58, and that is present, it's strong enough. There's no benzene ring, carbon to hydrogen, but there was a carbon to hydrogen single bonded atom right here to the right. The reading for that was 2,973.46. There's no carbon double bonded to oxygen. There was a CCl present. The example of strengths for your IR, even though the CCl is present, it is not strong enough to be in the absorption range. And there was no CR, or no C to Br. Alright, next, this is your NMR for 88D. As you can see, there are two peaks present. What do the peaks mean? The number of peaks means a different amount of hydrogens in your molecule, so 2 peaks means 2 different hydrogens. One of the readings at one of the peaks was 9, the other one was 1, which means your ratio is 9 to 1. With all this information, with the IR and NMR, I discovered that it was TB1. And this right here is just a structure of TB1. Alright, next, 88J. On the top is my IR spectra, on the bottom is my NMR. Okay, so using the same exact procedure, what I found out was acetone. Examining my NMR, there was only 1 peak with a ratio of 1, the number on it was 1, which means since there's 1 peak, there is no ratio. Once again, after doing all this, I found out it was acetone. And here's a structure of acetone. Alright, next I had 88L. I discovered using the same exact procedure as I did before. It was 1,2-dichloroethane. There are 2 peaks, which means 2 different hydrogens. Again, each had a reading of 1 to 1, which means the ratio is 1 to 1. And once again, it was 1,2-dichloroethane. And right here is another structure. Alright, so in conclusion, so what I learned throughout this experiment, which you should learn too, how to use an IR and NMR spectra, how to examine them to identify any unknowns given, any molecules that are given to you, and there's my works cited. Any questions?